Hello everyone, in this video we are going to do some more problems on the combined gas laws and gas laws. So I'm still working on worksheet number 2. So let's do question number 25 of worksheet 2. So the question says 500 ml of a gas was collected at 20 degrees Celsius and 720 mmHg of pressure. What is its new volume at STP? Now remember, I told you have to memorize the STP conditions. STP stands for standard temperature and pressure, right? So let's write down all the variables first. So you are given the volume of a gas, which is 500 ml, okay? And then you can convert that into liters. So that would be 0.5 liters, right? And then the temperature T1 and pressure P1 are given to you. So T1 is 20 degrees Celsius, which means 20 plus 273, that would be 293 kelvins. Okay. Then you are given the pressure P1, which is 720 mmHg. You can convert that into atmospheres. 1 atmosphere equals 760 mm. Then it will be easier because we can then use the pressure in atmosphere for the standard temperature and pressure condition. So convert that into ATMs. So 1 ATM equals 760 mmHg. So that comes out to be 0.947 ATM. Now the new set of conditions, since we have to solve for volume V2 at STP, right? So what does STP means? STP means standard temperature and pressure. Standard temperature, which is 2, so this is at STP, right? So temperature, standard temperature is always 273 kelvins or 0 degrees Celsius. Since we need kelvins in the temperature scale, we are using 273 Kelvin. And standard pressure is always 1 atmosphere, right? That is why we converted the mmHg to ATMs, or you could have used 760 mmHg here, right? Now since we have all three variables, meaning only the number of moles are constant, so this is a combined gas law, which is P1 V1 over T1. This should be equal to P2 V2 over T2. So you can rearrange this equation since we are solving for volume at STP, right? So you can rearrange this equation to solve for V2. Okay, so if I can rewrite this equation to solve for V2, this comes out to be P1 V1 times T2 over T1 times P2, right? So you can see, you can just cross multiply and then rearrange the variables to solve for V2, and then you plug in all the numbers. So V2 comes out to be 0.947 ATMs. Then V1 volume is 0.5 liters. Then T2, which is 273 kelvins. And then in the denominator we have T1, which is 293 kelvins, and P2, which is 1 ATM. Okay. Now you can cancel the units that are same in the numerator and denominator. ATM goes with ATM, Kelvin cancels out with Kelvin, and you will get your answer in liters. And you plug in all the numbers in your calculator and you will see you will get 0.441 liter for your answer. Okay, just double check. I just copied the answer from here. Okay, so next we are going to work on problem number 27. Okay, so you're gonna see similar problems on your next quiz and test as well. Okay, so how do we solve these type of problems when there are no values given for the temperature and pressure? Right? So if the absolute temperature of a given quantity of gas is doubled, so temperature is doubled, right, and the pressure is tripled, what happens to the volume of the gas? So now for these type of problems, you can assume either like some easy values like multiples of tens, right? Or what I like to do is I can just write temperature 1, T1 says T kelvins, right? Now since the new temperature of the gas was doubled, so I can say the new temperature T2 is 2T kelvins. Okay, so T1 was T. You can assume some numbers. You can think of some numbers. Maybe if it was 10, then that would be 2 times 10, that would be 20 kelvins, right? So or you can just keep it as T in terms of T. So if temperature 1 is T kelvins, the temperature, the new temperature was doubled, right? So that would be 2T. And pressure was tripled. So if the initial pressure P1 was say P atm or any other unit, right? Or you can just think of some number here. And since the new pressure was tripled, so P2 would be 3P, right? Now since we are also solving for the volume, right? So initial volume was say V1. V1 was the initial volume and V2 is what we are solving for. So we will solve V2 in terms of V1, right? So this is a combined gas law. Right? And the equation is P1 V1 over T1. This is equal to P2 V2 over T2. Right? Since we are solving for V2, so rewrite this equation in order to solve for V2. So if you cross multiply, you're going to see V2 comes out to be equal to P1 V1 times T2 over that would be T1 times P2, right? So now let's plug in all the values. V2 is pressure 1 is P, right? So I'm gonna write P. V1, let's keep it as V1, and temperature 2 is 2T, so I'm going to write, so let's put that in parentheses. So this is 2T. T2 is equal to double the initial temperature, so 2T, and then in the denominator we have T1, which is just T, so I'm just going to write T times P2. The new pressure was tripled, right? So this would be 3P. Now you can cancel out the things that are same in the numerator and denominator. So P cancels with P, T cancels with T, right? And then we have V2. Okay. So now you can actually see what happens to the pressure. So this cancels out, right? Now what we are left with is we have V1 here and V2 here. So V2 is equal to 2 by 3 V1. So the new volume decreases by 2/3 of the initial volume. So this would be your answer. Right? Okay. Guys, next we are going to do number 28. So let's do number 28. So number 28 is a cylinder with movable piston contains 2 grams of helium at room temperature. More helium was added to the cylinder and the volume was adjusted so that the gas pressure remained the same. So this means we have pressure which is constant. The pressure is constant. Okay. Now we had 2 grams of helium in a container, right? So let's say this was the container and it initially had 2 grams of helium gas, and we added more helium to the container. Let's say we added more, right? So we can find out how much more helium was added if we know the initial amount, right? So because the volume changed. Okay. How many grams of the helium were added to the cylinder if the volume was changed from 2 liters to 2.7 liters, right? So we have V1 which was 2 liters and V2 which is 2.7 liters. Okay. So let's write down the variables. So N1, since this is Avogadro's law, right? So that means V1 over N1 is equal to V2 over N2. Okay. So now let's write down all the variables first. So you are given N1, but since we have 2 grams, you need to convert the grams to moles first. The molar mass of helium is 4 gram per mole, right? So you can convert 2 grams into moles. So that would be 2 over 4, right? That would be probably 0.5 moles of helium is given to you. The initial volume is 2 liters and the new volume, the volume changed to 2.7 liters. Volume increases, so we should have more moles, right? Because more helium was added to the existing amount. So you can solve for N2. Okay. Now V1 over N1 is equal to V2 over N2, and we can solve for N2. N2 would be the total moles, right? So that would be N1 plus the added amount, right? So let's solve for the total number of moles. So if you rearrange the equation, you are going to get N2 is equal to V2 times N1 over V1. So this is how we solve for N2. Okay. Now plug in the numbers. Number of moles comes out to be V2 is 2.7 times N1 was 0.5. So this was liters, this was moles, and then divided by 2 liters. So liters and liters cancel, you get your answer in moles. So if you solve that, you will get 0.675 moles. So this is the total number of moles, right? That was N2. Okay. Now since you added more moles to N1, right? So we need to subtract the existing number of moles, the ones that we had initially, from the total number in order to get the amount of helium that was added. We want our answer in grams. How many grams of helium were added to 2 grams, right? So convert 0.675 moles into grams first, right? So again, so this would be 0.675 moles helium equals 1 mole of helium is 4 grams, right? Helium. So if you convert that, this number comes out to be 2.7 grams. Right? Now this is the total amount of moles after some helium was added, right? In the beginning we had only 2 grams, right? So amount of helium added to the container, to the cylinder, were 2.7 minus 2 grams. This is the amount that we had initially, right? So the answer would be 0.7 grams helium was added. Okay, so hope that is helpful, and I will make another video on the inert gas and the gas equation.